Uh, Dear friends, today we will discuss another article in our chapter number 2, that is partial differentiation. The title of this article is this: change of variables from Cartesian to from Cartesian to polar coordinates. See, in physics we come across different types of problems: linear motion, circular motion, then in heat and thermodynamics, in several other branches of physics. We know that each problem has its own advantage as well as disadvantage, or sometimes we call it symmetry. Based upon the symmetry, we have to choose a proper coordinate system. So sometimes solving a problem of circular motion in polar coordinate is more easy as compared to this xyz coordinate or Cartesian coordinate, or every coordinate system has its own advantages and own disadvantages. So here in the differential equation also, we can use this type of transformation equations between two coordinate systems to change our partial differential equations or total differential equations. In today's discussion, we are going to discuss how these things can be carried out. So here we are going to discuss one such very simple frame, that is the polar frame. So I'll draw this simple diagram that will give us an idea what this frame is. Now this is my two-dimensional XY Cartesian coordinate system frame, and let's suppose this point P to be having its coordinate as x and y in Cartesian, whereas this point P will have its coordinates as r and theta. To get the transformation equations between these two, we have to draw a position vector from the origin to this point P here. Okay. Let's suppose this is point P. Now what is the angle made by this vector r bar? This is r and this is theta. So r and theta are these two coordinates. So length of this vector or length element from this origin to this point P is taken to be r, and angle made by this r with this x-axis, that is taken to be theta. So these are the two new coordinates, and from this diagram we can very easily find out what are the transformation equations. Suppose this will be y and this will be small x. So you can use this right angle triangle method to find out this sine and cos of theta. So that diagram shows you sine theta is equal to y upon r, and therefore I will get y is equal to r times sine theta. This is one transformation equation. Similarly, getting cos theta here will be again, this is what the side here, x divided by the hypotenuse r, so that is x upon r, and therefore another transformation equation I will get x is equal to r times cos theta. So remember, these two transformation equations we are supposed to use here in getting this type of this particular derivation, change of variable from Cartesian to polar coordinates. Okay, so here let us have a function capital F, which is a function of two independent variables x and y x and y, where x and y are independent, that and depending upon that f function has different values. So that is what f of xy. Then the Cartesian coordinates are related to polar coordinates. These equations what we have written earlier. So x is given to be r cos theta. So I can write this relationship: x is a function of two independent variables r and theta, and y is given by r times sine theta. This is r. So here also I can write another relationship. Y is a function of r and theta 2. Now, like here we can use a chain rule. So when either r or theta changes, x changes as well as y changes, and therefore capital F2b changes. So we have to get a partial derivative of f with respect to r and partial derivative of f with respect to theta. That derivatives can be used to find out partial derivative of f with respect to x as well as partial derivative with respect to y as follows. Okay, so we can use here chain rule. If I know this relationship using chain rule, now there will be two chain rules we already know, because there are two independent variables where this x and y depends upon, that is this r and theta. So there will be two chain rules. Naturally, first chain rule will be delta f upon delta r. If you remember, yesterday we have seen this. This is given by partial differentiation of f with respect to x into delta x upon delta r, plus second term in this case will be delta f upon delta y into delta y upon delta r. But this delta x upon delta r and this delta y upon delta r, they can be taken from the above equations, because we know the relations between x and r theta as well as y and r theta. X is equal to r cos theta, y is equal to r sin theta. Therefore, using this, I'll get, if I go for this calculation, delta x upon delta r. Okay, this differential will be delta by delta r of, this is r times cos theta. So this differential is minus, sorry, not plus, this r will be differentiated r only, and therefore it simply comes to be cos theta. Similarly, another differentiation, delta y upon delta r, if it is taken, here also we will get this to be y is r sin theta, so its differential is again simply sin theta, isn't it? And if I use this case here, I'll get this to be delta f, capital F upon delta r is equal to this delta f upon delta x remains as it is, into this is cos theta, plus this is delta f upon delta y into this is simply sin theta. Okay, call this to be equation 1 in this case. Now go for the second partial derivative, that with respect to theta. So I will get similarly I can write delta f upon delta theta is equal to, again use the chain rule, same chain rule here. So this is delta f upon delta x into delta x upon delta theta plus delta f upon delta y into delta y upon delta theta. Again here these two relationships can be used here. We have x is equal to r cos theta, therefore delta x upon delta theta will be, r will remain as it is, and differential of cos theta is minus sin theta, and therefore this is minus r times sin theta. This is the derivative of x with respect to theta. Similarly, delta y upon delta theta will be equal to differential of this, y is r sin theta, so differential of r sin theta, r remains as it is, and differential of sin theta is cos theta, therefore this value is going to be r times cos theta. So using this here, delta x upon delta x upon delta theta and delta y upon delta theta, from this I can get another equation number 2 is delta f upon delta theta is equal to, this is delta f upon delta x, then this is minus r times sin theta and plus delta f upon delta y, and this is r times cos theta. Call this to be equation 2. Now I have to get the relations between delta f upon delta x and delta f upon delta theta and delta f upon delta r. Similarly, I have to get relation between delta f upon delta y and delta f upon delta r and delta f upon delta theta. For that, we have to do certain manipulations over these equations 1 and 2, and these are as follows. Okay, now multiply equation 1 by r cos theta and equation 2 by sine theta. So this multiplication. Now because of that, let's check what happens to this equation 1 and 2. Equation 1, left hand side becomes r times cos theta into delta f upon delta r. Now first term here was containing cos theta, so cos theta into r times cos theta is r times cos square theta, and this delta f upon delta x as it is, so it becomes r times cos square theta. This is first term on the right hand side, and plus the earlier term was delta f upon delta y into sin theta, and if it is multiplied by r cos theta, this becomes delta f upon delta y into the bracket r sin theta cos theta. Okay, we can call this to be equation 3. Similarly, multiply equation 2, this one, by sin theta, and let's check what we will get. Left hand side is sin theta into delta f upon delta theta is equal to Subhash, hello, इधर बोल ना था, आई एम टेकिंग लेक्चर, बोल ना था लेक्चर में. Second is sin theta upon delta theta, so this becomes, now it is delta f upon delta x, and if it is multiplied by what we are multiplying this second equation by sin theta, so this becomes this equation 2 becomes equation 2 becomes, this was r sin theta into sin theta, so that becomes minus r into sin square theta. Okay, so this term plus delta f upon delta y, and here it was, this is r cos theta multiplied by sin theta, so this becomes r times sin theta cos theta. Now here this is my equation number 4. Look here, this term and these terms are identical, this term and this term are something different. Okay, so term first here and term first here are different, they are having this type of trigonometric relations one can get from here, whereas these two equations, these two parts of this equation 3 and 4 are identical, left hand sides are different. Now you have to subtract equation 4 from equation 3. So subtracting equation 4 from equation 3 and rearrange, what we will get, check. So this is r times cos theta into delta f upon delta r minus sin theta into delta f upon delta theta, this and this is equal to, here subtracting, this becomes plus and this will become minus, so this term and this term, they are going to get cancelled because of equal and opposite term when I subtract equation 4 from equation 3, and these terms will get added, and here delta f upon delta x is common, so in the bracket I'll get r times cos square theta plus r times sin square theta, and herefore this becomes simply r times delta f upon delta x. Okay, this, now here this I can write, change the sides, and therefore this can be written as delta f upon delta x is equal to r times cos theta into delta f upon delta r minus sin theta into delta f upon delta theta. Here take this r on the right hand side, and therefore I'll get a final expression here, differential of f with respect to x, partial differential of f with respect to x is equal to simply cos theta, this r will get cancelled, into delta f upon delta r minus, this time this r will come in the denominator, so sin theta upon r into delta f upon delta theta. Call this to be equation number 5. This is the change of variable, so that from x, or if we know r and theta coordinates and function f, we can find out this partial differential of f with respect to x. So this is our important relation, that is what the final relation we are supposed to get. Similarly, next relation we are supposed to get, that is deva f upon deva y in terms of this deva f upon deva r and deva f upon deva theta. To get this relationship, again we have to go for equation 1 and 2. So multiply equation 1. I'll just multiply this. Multiply equation 1 by a term minus r times sin theta, negative term, and equation 2 by cos theta, 1 by minus r sin theta, and equation 2 by cos theta. So you have already have all these equations. So let's check what we will get this equation 1 and 2 converted as. Minus r times sin theta, partial differential of f with respect to r is equal to first term as it is deva f upon deva x, and earlier it was cos theta multiplied by minus r sin theta, that gives you minus r sin theta cos theta. This is my first term, whereas second term was sin theta was multiplied there, so it is deva f upon deva y, sin theta multiplied by minus r times sin theta, so it becomes minus r sin square theta. Call this to be equation 6. And similarly equation 2 will be written as, if it is multiplied by cos theta into deva f upon deva, both of these f are capital F, remember, deva f upon deva theta is equal to, so first term it is deva f upon deva x into the bracket, it is minus r sin theta cos theta. Okay, check it. Earlier it was minus r sin theta, if it is multiplied by cos theta it becomes this. And similarly the next term is deva f upon deva y is r times cos square theta. Okay, so call this to be equation number 7. Try to get this term, how we have arrived at this particular equation. Okay, now subtract equation 6 from equation 7. So next is subtracting equation 6 from 7. Subtracting equation 6 from 7. Okay, 7, I am writing this in number. Note that I am subtracting this, or this first part, negative. When subtracting, this becomes positive, and this term here is a positive and negative. This one will become negative and second will be positive. So accordingly one can get this relationship as, and remember this term, I'll just take it down. Here this was minus r sin theta, this is cos theta. Subtracting this means this will become positive, this will also become positive. So this positive and this, here it is deva x. So this and this term will be identical and opposite, equal and opposite, so they will get cancelled. When we subtract this, so it becomes positive, this is negative, so that gets cancelled, and this is positive, this will become negative, so it will again become positive. So all the terms obtained here will become positive on both sides, and therefore we will get cos theta into deva f upon deva theta plus r times sin theta into deva f upon deva r. Okay, now is equal to, now again here I will get deva f upon deva y common from right hand side. These two terms are going to be cancelled with each other. In the bracket it is going to be r times cos square theta plus r times sin square theta. Again you can use that identity, cos square theta plus sin square theta is equal to 1, so r comes out, and therefore it is r times deva f upon deva y. Okay, rewrite, change the sides, so I'll get r times deva f upon deva y is equal to cos theta into deva capital F upon deva theta plus r times sin theta into sin theta into deva f upon deva r, deva f upon deva r. So again you can cancel r on both sides, so there will be r will come in the denominator for the first term on the RHS, whereas r will be cancelled on the second term in the RHS. And rearranging this, I'll get another equation, delta f upon delta y. Delta, this should be f everywhere, capital F, not small f. Okay? So this is here also. So delta f upon delta y is equal to, I am writing this term first, so it is sine theta times delta f upon delta r and plus cos theta upon r into delta f upon delta theta. Okay, and this is my equation number 8. So these two, equation number 5 and equation number 8, thus equation 5 and equation 8 connects the changed variables. So I'll get partial differentiation of f with respect to y, provided I know r as well as theta. And our earlier equation number 5 was delta f upon delta x. Okay, we have written it here. That was this, delta f upon delta x is equal to, this f is also to be a complete f like this. So it is cos theta delta f upon delta r minus sin theta upon r into delta f upon delta theta. So look at partial derivative of f with respect to theta, partial derivative of f with respect to r, and this is partial derivative of f with respect to x. And this equation 8 is also partial derivative of f with respect to r, partial derivative of capital F with respect to theta, and this is what partial differentiation of f with respect to y. So that is how we have shown in this derivation how the changed variables, or because of the change in the variables, how this partial differential equations gets in the different form, that is as shown by equation 5 and equation 8. Connecting to this, let's take one simple example, or how one can arrive at the same result if we apply usual method of differentiation and this change of variables method of differentiation. For that, let's write this particular statement of the problem. If this capital F is a function which is given to be x square plus y square that raised to half into y upon x, this is a function given, obtain partial differentiation delta f upon delta x directly, that means by usual method, directly, and by changing variables, xy to r theta, we have to change this variable, and let's get the solution of this problem. So we are supposed to get this partial differentiation of f with respect to x by two methods. One is our usual method you have to apply, second is the method just now we have learned, that how to by changing the variables x and y to r and theta. So corresponding equation for this delta f upon delta x, that is equation number 5, can be used here, and we will just check it there. Okay, now let's by direct method we'll get partial differentiation of f with respect to x. So this is nothing but delta by delta x of, now look at this, it is x square plus y square that raised to half, and it is y into x upon x. Note this is a product, so first differentiate this will remain as it is, second time keep it as it is, and differential of this, x is in the denominator, and here it is x square plus y square raised to half. So this differentiation with respect to x gives me 1/2 comes out, then this will be x square plus y square raised to half minus 1 is raised to minus half, and therefore this can be taken in the denominator, and therefore it becomes x square plus y square raised to half in the denominator. Okay, and similarly differential of this x square is now again twice x, and y upon x will remain as it is, this will remain as it is, differential of this is 1/2, 1 upon root of x square plus y square and multiplied by 2x. Similarly, in the next case, this x square plus y square raised to half, it will remain as it is, and differential of this y will remain as it is, not a function of x. Differential of this is, I am taking negative sign here, x square. So this term is going to be negative, and therefore rearranging all this, I'll get this as, okay, it is del by f upon capital F upon del by x, partial derivative of capital F with respect to x. Here this x, this two gets cancelled, and what remains is simply y divided by x square plus y square, that raised to half, minus here this x square is in the denominator, y is the numerator with negative sign, so minus sign comes out this, and therefore it is x square plus y square raised to half in the numerator divided by x square into this y as it is. This is my one of the solution. One by direct method, I got this to be a partial differential of f with respect to x. Okay. Now, by using the transformation equations, we have this x is equal to r cos theta and y is equal to r times sin theta. I can use this. So the differentiation or the partial differentiation of f with respect to x using the method of change of variables, equation number 5 in earlier discussion, we can write del by f upon del by x, okay, is equal to, this is what we have already written, cos theta into del by f upon del by r minus sin theta upon r into del by f upon del by theta. So refer to equation 5 in earlier discussion. That is what we have asked there. Now if had been we asked del by f upon del by y, we could have used this equation number 8 there. Here we have to use this equation number 5. Okay. Now let's check. We have been given f is equal to x square plus y square, that raised to half, into y upon x. Okay. How can we write? Now if I have this x and y, I'll get x square plus y square is equal to r square cos square theta plus r square sin square theta. This can be written as simply r square. Therefore this x square plus y square raised to half is nothing but r. Similarly y upon x, okay, so this y upon x is nothing but r times sin theta upon r times cos theta. So this can be written as simply tan theta. So this part and this r, I can write this function. So this function capital F can be written as simply, this is r, I am writing this function in terms of r and theta. So this is r into tan theta. Okay, you can call this to be equation 3. This is actual, the function given in the form of x and y is this. If it is converted using this transformation equations, gets converted into f is equal to r times tan theta, because we have to get differential of f with respect to r and f differential of capital F with respect to theta too. To do that calculation, we need this type of transformation here. Okay, so using this chain rule, using this rule already we obtained. Therefore del by f upon del by x is equal to cos theta into del by r of the function given capital F is r times tan theta minus sin theta upon r, this remains as it is, into del by theta of again r times tan theta. By using this change of variables, this is the expression, change of variables, we have used this differentiation equation. Okay, now cos theta will remain as it is. Differential of this theta, tan theta is not function of r, so only r is function of this, so I can write this is to be simply tan theta minus sin theta upon r will remain as it is. Now differential of r with respect to theta is not needed because r is not function of theta, so it will come out of as it is into r, and differential of tan theta with respect to theta, I'm sure lot many may not be knowing this. This becomes to be sec square theta, differential of d by d theta of tan theta is equal to sec square theta. This is one standard format or standard differentiation of tan theta gives you sec square theta. Okay, now if I am going to get here, this r gets cancelled, so next is cos of theta into tan theta minus sin theta into sec square theta. Okay, so this is my deva f upon deva x, partial differential of f with respect to x. But can you see this? Now whatever I am getting here, that my equation, I can call this to be equation 1 and 2. This is fourth. Okay, so equation 4 is this, and what I obtained by this method is here. This is y upon x square plus y square raised to half minus x square plus y square raised to half upon x square into y. That is my equation 1. That is what partial differentiation of f obtained by direct method is as shown here. By using this change of variables, I have obtained this. Now I have to show that whether this is exactly similar as equation 1. So here, now remember this if I have this triangle, I have a triangle, this is theta, if it is x, and this is y, and then this is r. Okay, I can write cos theta is equal to y upon r, sorry, x upon r, and sin theta is equal to, actually I am writing it here, cos theta is equal to y x upon r, and therefore this can be written as x upon, already we have seen this r is given by root of x square plus y square raised to half. So this is x square plus y square that raised to half. So that is why my cos theta. Okay, sin theta is y upon r. So here also this can be written as y upon x square plus y square that raised to half. This is one more thing, and already we have seen this tan theta is nothing but, we have seen written this, that tan theta is y upon x. So converting this or writing this here, I'll get deva f upon deva x is equal to cos theta is x upon x square plus y square that raised to half, and tan theta is y upon x, minus sin theta, as I just now seen, sin theta is y upon x square plus y square that raised to half. And what about this sec square theta? Sec square theta is the, okay, so how many of you know the relationship between sec theta and cos theta? So 1 upon cos theta is equal to sec theta. Okay, and 1 upon sin theta is cosec theta. 1 upon okay, so sec theta, cosec theta, and third 1 upon tan theta is cot theta. Okay, so that is the, now cos theta is x upon x square plus y square raised to half. Therefore sec theta can be written as, therefore sec theta is equal to 1 upon cos theta. Writing this in the denominator, it becomes, I can write this to be as x is the denominator, so it becomes x square plus y square raised to half in the numerator, and x is in the denominator, and therefore sec square theta is, this is square of this x square plus y square raised to 1, because this 1/2 is there, and this is denominator is x square in the side here. Okay, so here I have to write this to be equal to x square plus y square raised to 1 divided by x square. So rearranging this again, therefore I'll get deva f upon deva x, partial diffusion of f with respect to x. This gives me x upon x square plus y square raised to half into this x is going to cancel, so this is simply y. This x and this x gets cancelled, so I'll get this y minus, here also this square root bracket, x square plus y square raised to half, x square plus y square raised to 1, so 1 minus half is 1/2, so numerator comes to be y upon x square, and this is x square plus y square raised to half. This is my equation number 5. Now look at this equation 5 obtained by this change of variables method, and the equation obtained by direct method, that is what equation 1 we have obtained. Just check this, these are exactly similar relations. So this is what we have shown. This actually y I can write this y to be here, so x square, so here this y can be written here, so x square plus y square raised to half upon x square into y. So that is how equation 5 and equation 1, these are found to be identical. That's what, using direct method as well as using this method of changing the variables, we get same partial differentiation of f with respect to x. Similarly, you can go for next. I am giving this is a small exercise here. You can go for exercise you can do at home. So obtain deva f upon deva y using change of variable methods and direct method. You have to apply same method what we have discussed just now. That completes this small derivation, that is change of variables from Cartesian to polar coordinates. In our textbook there are several such type of problems are also given. As in a practice session we'll go for some of the problems there. Okay, so thank you for kind cooperation of this, and now we'll stop here.